So let's look at the first question. So there is a graph given. It's one linear function, and that's y equal to 4x. If you be able to do this worksheet, you will be able to do the questions that I will put out of 6-2. So the worksheet is pretty comprehensive. So we're going to do multiple questions out of this worksheet. Okay, so it's a linear function and also a cubic function, y equal to x cubed. The area in between two is highlighted. So now they are asking for each problem, set up an integral to compute the volume of the solid obtained by rotating this region about the given line. So let's start with the first one, the x-axis. So I want all of you to graph the two functions in your notes and then think about it. You remember yesterday I said take a chunk and rotate it? Let's just take a chunk. So graph both, take a chunk and rotate it, and then put the result of the rotation somewhere outside. See what you have. So I'm going to give you a minute, copy it down. And then the first one is rotation about x-axis. I turn off my camera because I'm working with two devices, so I don't know the direction of my video when I put my computer this side and that side. But yeah. Okay. So let's do it. So rotating about x-axis, you take a chunk, if that makes sense. And then you rotate that chunk or that rectangle around the x-axis because that's the axis of rotation here. So the shape that I will have outside will be this vertical cylinder, or if you call it horizontal cylinder because the height is horizontally, or whatever you call it. And that's dx because I'm cutting it off of x-axis. And then the radius, do you see that when you're rotating, there is an empty space here? So basically, because there is a distance from the second one down, so that there is a hollow inside this shape. Do you agree? So in order to find the volume of the solid, I want you to be with me. So in order to find the volume of the solid, I need to find the volume of the outside one minus the volume of the inside one. So it seems that there are two cylinders, the outer one and the inner one. To find the volume in between, I need to say volume of the outer minus the volume of inner. Does that make sense? So I'm going to mark the radius of the outer one with blue. So the radius of the outer one, it's all the way from the center, from x-axis to the edge of the linear function. So it's 4x, or y equal to 4x. And for the smaller one, I'm going to mark it with pink. And that comes from this yellow one that you see I'm marking here. Or let me pick another color, red. So do you see it comes from the inner one, which is just going to the edge of this cubic function. So for the inner one, the radius is y equal to x cubed. In order to find the volume in between, I need to find the volume of the outer one. So I set up the integral. It's gonna be dx. So keep that in mind. So the outer one, pi r square h. So pi r square h, that's the outer one, minus pi r square h, the inner one. So I'm going to mark it, the outer, the inner. So that would be, if I write it as one thing, it's pi r square, and I'm going to put it as one integral for now. I'm going to factor out pi from both of them. So pi and dx for both of them. So it's 4x squared minus x cubed square, and then dx. That's the setup. And then you evaluate from there. Make sense? So now you need to put the limits. It's dx. So I need to go from minimum to maximum of x. In this case, what is the minimum and maximum of x? X goes from 0 all the way to 2. So when you are finding the integral, you just say pi 0 to 2. I want to give you a minute, calculate this integral. Okay, tell me. You need to write that as 16 x squared minus x to power 3 to power 2 is x to power 6. And then dx. And then you go ahead and calculate from here. 16x cubed over 3 minus x to 7 over 7 from 0 to 2. Whatever is the result, multiply that by pi. And then I bet you can do it. Just substitute. Okay. What did you get as your final answer here? The answer is also on the next page. If you want to check, 512 over 21 pi. Upper minus lower. Keep going. Okay. Well, I think the number should be bigger than that, Greg, if you check again when you get common denominator. Okay, So let's do the second one. Now I want you to regraph the graph. Because I'm going to erase what you have, and then for second question is referring to the same graph, but I want you to regraph it. So put the linear function, put the cubic function from 0 to 2 horizontally. 0 to 8 is their 0, 0 basically, and 2, 8 is the intersection of the two functions. Okay. So can I erase this one? I need this space. Anyone needs it? You got it? Okay. So now let's do the second.